Looking at the Earth from space, there is water everywhere. Clouds, oceans, ice, and life forms everywhere. In fact, no other planet in the entire solar system is so rich in water as the Earth. Seen from space, the Earth is a shining blue planet, blessed with such abundant water resources that it is also called the water planet because of its appearance. It is said that 2/3 of the Earth's surface is covered with water, which amounts to about 1.4 billion cubic kilometers, 97.5% of which is seawater and only 2.5% is fresh water. Most of this fresh water is found in the form of ice and glaciers in the Antarctic, Arctic, and other regions. Therefore, the amount of fresh water in the form of groundwater, rivers, lakes, and other water sources is only about 0.8% of the global total. Furthermore, since most of this water is groundwater, only 0.01% of water exists in rivers, lakes, and other bodies of water that are easily accessible to humans. Water is a special and mysterious substance, with properties that are completely different from those of other substances on the Earth. It is no exaggeration to say that the very existence of water on the Earth is a miracle. Water changes its shape under the influence of temperature. When the temperature falls below 0 degrees Celsius, it becomes ice, and when heat is added and certain conditions are met, it evaporates and becomes water vapor. Let's take a look at some of the wonders of water. The first is about clouds. Looking up at the sky, it is easy to spot clouds, isn't it? These clouds are made up of altered forms of water. When water from rivers and oceans evaporates, water vapor rises into the atmosphere. As this water vapor rises and cools in the atmosphere, it turns into tiny water droplets and ice particles that form clouds. So water in rivers and oceans evaporates with the heat of the sun, becoming water vapor, which cools and forms clouds. We still don't fully understand the phenomenon of water evaporation. To begin with, I think people have a strong image that water starts boiling at 100 C. But even if the temperature is low, water itself is a molecule, so as long as it has energy, it becomes active and water evaporates up to the saturation vapor pressure at the temperature of that location. Thanks to this, laundry can be dried, even if the temperature does not exceed 100 C. In everyday situations, if water is in a warm place, and the surface area of the water is large, it will evaporate more easily. But the important thing is that there is almost no other substance other than water that has these properties. And since seawater contains salt and impurities, it should theoretically be even more difficult to evaporate. Even so, the mechanism by which it evaporates to form clouds is not fully understood. Another mysterious mystery is the unusually strong surface tension. This surface tension is the force that prevents water from spilling, even if a little more water is added than the height of the rim of the glass. This is the force that tries to reduce the area in contact with the interface as much as possible, and since water molecules do not want to be in contact with air as much as possible, they try to move inside the cup as much as possible, which causes the surface of the water to rise slightly. It is said that this property allows plants to absorb water from the soil and spread it through the air to the leaves and flowers. Conversely, if water did not have this property, such plants would not be able to reproduce on the Earth, and without it, oxygen would not be produced. In other words, we humans would not be able to survive on the Earth. We are thankful for water. Next is the magical property of water that ice floats on water. Most substances in the world decrease in volume when cooled and increase in volume when warmed. Simply put, when warmed up, the shape of a substance expands greatly. The reason for the decrease in volume is that the space between molecules becomes smaller, and conversely, when warmed up, the space between molecules increases and the volume becomes larger. For example, if you put an iron vessel made of the same iron into molten iron that has turned to mush, it will sink. Most substances other than water sink when an individual of that substance is placed in a liquid. Conversely, when water changes from a liquid to a solid, its density becomes smaller. In other words, it becomes lighter. When we hear the word solidification, we have an image of density becoming larger. But it is strange that it becomes lighter even though it is the same substance. When it is put back into water, it becomes heavier. This is an unusual property of water. If you fill a glass with water and put it in the refrigerator overnight, of course, the water will turn to ice, and if that container is filled with a glass cup with a lid, that cup will break when you wake up in the morning. The reason for this is that when water goes from a liquid to a solid, its density decreases and its volume increases. In other words, when it becomes solid, it expands, and this is why the cup breaks. For example, if solids were denser than liquids and water, lakes and oceans would freeze completely in winter. The fish that live there would also be iced over. But in reality, because of the ice's ability to float on water, the lake would have ice on top and water underneath, and the fish would not freeze. The temperature of water at which its density is greatest is 4°C, and as it cools further, its density decreases again. In other words, water at 4°C is the heaviest. Therefore, the water under a frozen lake is 4°C. The same is true of the oceans. Normally, you would think that the deeper the ocean gets, the colder the water gets, but at depths deeper than 1,000 meters, the water is always around 4°C. Water is a mysterious thing that is conveniently created for us humans on a global scale. The human body is also composed of 60 to 70% water. Where in the body does water reside? When we think of water in the body, the first thing that comes to mind is blood. The human body is composed of a collection of cells, and the water contained in the more than 60 trillion cells accounts for 2/3 of the total, with the remaining 1/3 in the intercellular fluid that exists between cells and in the blood, each working to sustain life. In fact, blood is only 1/12 of the total. In fact, an enormous amount of water is positioned as an important presence in the body. A newborn baby is composed of about 75% water, and as we age, the amount of water in our bodies decreases. Fat replaces water. In old age, intracellular water also decreases, to nearly 50%. Even so, the role of water in the body is very important. The role of water in the body is still very important. You can tolerate food for 3 weeks, but not water for 4 days. There are other wonders of water. Recent research has shown that liquid is the most powerful storage medium for information. And it is said that a spoonful of liquid can store 1 terabyte of information. In other words, it is predicted that in the future, memory will be liquid. So, when we think about how much information can be stored in the past history of the Earth, and what can store such a huge amount of data, the only thing that can store it is water, or liquid.